Hello and welcome to The Whispering Scientist. It's lovely to have you here tonight. This space is designed specifically for winding down, for slowing the mind, and gently floating into rest, while perhaps learning something quietly fascinating along the way. So, as you settle in, make yourself completely comfortable, soften your breathing, and allow the weight of the day to loosen its grip on you. Let every thought, every task, and every moment of rush drift away, replaced only by the soft, distant quiet of the cosmos. This evening, we're drifting toward one of the most mysterious wonders of our solar system, the planet Saturn. It is a world so enchanting, so seemingly impossible in its sheer presence that it almost feels like a cosmic illusion. Before we begin our quiet journey among its shimmering rings, here is a simple thought to carry with you. How can a planet so gigantic, wearing rings that stretch for hundreds of thousands of kilometers, exist in a way that seems to make no sense at all? Saturn is often described as the jewel of the solar system, yet the more we learn about it, the more it behaves like a celestial contradiction. It breaks the instinctive rules we might apply to something so vast. It is enormous yet strangely light. Its rings appear ancient and timeless, yet they may be far younger than we imagined. And how can a world made mostly of gas manage to create structures, patterns, and storms with the elegance of a cosmic clockmaker? Tonight's journey will gently explore these impossibilities, allowing each idea to settle slowly like stardust as we drift through the serene beauty of Saturn's cloud tops. The delicate choreography of its icy rings and the quiet behavior of its many moons. We won't rush. We'll simply glide. Imagine for a moment that you are moving through space in a state of perfect calm. There is no engine noise, no rush of air, no vibration beneath you, just stillness and a deepening silence. Ahead of you, Saturn grows gently into view, wrapped in its delicate, bright rings like a lantern surrounded by a soft, ethereal frost. Starlight catches on the countless particles circling the planet, making them glimmer as though someone has dusted the cosmos with crushed diamonds. You are drifting toward them slowly, as if the universe itself is inviting you to take your time and observe without urgency. As you draw nearer, the rings separate into recognizable bands of brightness and shadow, forming broad, graceful arcs that stretch across the darkness. They appear smooth and solid from afar, almost like a single halo of polished glass. But as you approach, that visual illusion softens. The rings begin to reveal their true nature, not a single surface, but a vast and intricate collection of icy fragments. Each one is dancing along its own precise orbital path. Some pieces are as small as grains of sand, while others are closer in size to a house. Together, they form a glittering ribbon that circles Saturn in a silent, perpetual ballet. Passing through the edge of the ring plane feels like drifting through a cloud of frozen lace. A soft, distant haze surrounds you, illuminated by the faraway sun. The sunlight here has traveled for over 1 billion kilometers to reach Saturn, and it arrives gentler and fainter than the sunshine we know on Earth. Yet, even in this dimmer glow, the rings shine with quiet brilliance, as if the cold of space has polished them to perfection. From this close perspective, you may notice something truly surprising. For all their breathtaking width, a span so vast that if placed around Earth, they would reach far beyond our own moon, the rings are astonishingly thin. Vertically, they are no thicker than a few large buildings stacked one atop another. Imagine a sheet of paper spread across a vast, empty field. That is the kind of scale difference we are dealing with. The rings are like a cosmic whisper, wide, delicate, and almost weightless in comparison to the enormous planet they surround. As your eyes adjust to the details, the 3 main bands of the rings become easier to distinguish. Closest to the planet, you find the C ring, faint and ghost-like, letting much of the light slip through. Beyond it lies the B ring, The brightest and most opaque of them all, a sparkling band of densely packed ice that reflects sunlight like a beautifully frosted mirror. And further out, sweeping elegantly into the darkness, is the A ring, broader and slightly more translucent. Separating the A and B rings is a notable dark gap known as the Cassini division, a subtle boundary where fewer particles drift. It is not empty space, but it is sparse enough to appear like a deep breath taken between two bright, graceful brush strokes of ice. The particles themselves are made primarily of water ice, often pure enough to gleam in the distant sunlight. Some contain a dusting of darker material, tiny flecks of cosmic debris and organic compounds that have settled over time. But at this soft introductory moment, the details do not need to be dissected too quickly. It is enough to know that the rings are formed from countless frozen fragments, circling Saturn in a graceful, ever-moving tapestry. Drifting with these particles, you might notice how peacefully they travel. There is no sound here, no crashes or clattering as one might imagine from a collection of countless orbiting objects. Collisions do happen, but space has a way of slowing the chaos. When one fragment meets another, they often nudge gently, transferring a little motion, then continue along their path. This delicate balancing act helps keep the rings looking so smooth and serene from afar. What makes the experience so mesmerizing is how the rings interact with light. Each tiny piece reflects and scatters sunlight, creating shifting patterns of brightness. When the sun is behind the rings, they appear translucent, glowing softly like frosted glass held up to a window. When the sun shines upon them from the front, they can dazzle like freshly fallen snow. The effect changes as you move around them, turning the rings into nature's subtlest light show. As you drift just above the rings, the planet begins to dominate your view. Saturn's cloud tops appear smooth and striped with gentle bands of cream, gold, and muted grey. Shadows from the rings fall across the planet, painting elongated arcs of darkness over the atmosphere. These shadows add to the peaceful ambience, as if night and day have merged into a single, tranquil canvas. To the human eye, Saturn feels timeless, as if it has worn these rings since the dawn of existence. From this quiet vantage point, floating in the soft glow of reflected sunlight, it is easy to believe that the rings are ancient, unchanged, and eternal. They look so perfect, so complete, that it is hard to imagine the planet without them. Yet appearances can be deceptive. The rings hold secrets that the universe has been patiently keeping, waiting for curious minds to notice that all is not as it seems. They may look everlasting, but their story is far more delicate than that. As we continue to glide above this icy halo, keep that quiet question tucked away. How did such a thin, delicate formation appear around such a massive world? It seems almost too graceful to belong to something so huge. The answer lies in understanding Saturn's nature itself, the curious balance that allows something so fragile to exist around a planet of such immense size. If you enjoy these calming bedtime explorations, a gentle tap on the like and subscribe buttons would mean a lot to the Whispering Scientist. Your support helps this sleepy little corner of the universe keep growing. As we begin this gentle journey, there is a question worth holding in the back of your mind. If Saturn truly shouldn't exist the way it does, what does that say about the universe that shaped it? As you continue your gentle glide above Saturn's realm, the initial illusion of the rings as a solid, polished band fades entirely, replaced by a sight of far more intricate and delicate beauty. You are now moving through the very edge of the vast, shimmering sheet, and the truth of its composition begins to unfold around you. The rings are, in essence, a vast, silent snowstorm of orbiting ice. They are composed of countless icy fragments, each one a miniature world, following its own path in perfect obedience to Saturn's massive gravity. These particles vary enormously in size, contributing to a finely textured, ethereal structure that gleams with an otherworldly beauty. Some are microscopic dust motes, so small they would disappear between your fingertips if you could hold them. Others are the size of pebbles, small snowballs, or chunks of ice resembling pieces of broken sculpture. There are even fragments the size of a small house or a large boulder, though the majority of the material remains at the smaller, dust-like end of the scale. The overwhelming composition of this dazzling display is water ice. This ice, in many places, is remarkably pure, which is the source of the rings' incredible brightness and their highly reflective quality. When the faint, distant sunlight strikes these icy surfaces, it bounces off with great efficiency. This brilliance, this shimmering glow in the deep cold of space, is one of the primary reasons Saturn's rings stand out so vividly in the night sky, even from Earth. Along with the pure water ice, the rings contain small amounts of dust and darker organic molecules, adding faint, subtle touches of color and complexity. Now imagine drifting with these particles. There is no turbulence, no roaring sound, only the vast, quiet ballet of motion. The particles move through the rings in an organized harmony, a layered flow where inner fragments travel faster, much like a car on the inner lane of a circular track, and outer particles move more slowly. This difference in speed is crucial. It means the particles do not move as a single, fragile sheet, but rather as an infinite set of swirling, coordinated lanes gliding past one another without great disruption. Despite the calm appearance, gentle collisions occur constantly within the rings. Particles bump into each other, transferring small amounts of energy. But unlike collisions here on Earth, which can be violent or loud, these impacts are more like the soft tapping of snowflakes settling together. Space has a way of slowing the chaos. Over long spans of time, these countless small encounters work as a quiet sculptor, helping to keep the rings astonishingly thin and flat. If a particle strays slightly upward or downward from the main plane, collisions and gravitational nudges quietly guide it back into the shared, level sheet. If you could, for a moment, hold one of these fragments in your hand, you might find it resembles a snowball, cold, compact, and glistening. Some particles are fluffy and loosely packed, while others are solid and icy, like tiny frozen diamonds. Together they create a scene that feels both strangely familiar and deeply otherworldly, a place where the rules of scale and material have been completely rearranged. What makes this experience so truly mesmerizing is the dynamic way the rings interact with light. Each tiny piece of ice reflects and scatters the distant sunlight, creating ever-shifting patterns of brightness and shade. This effect depends entirely on your vantage point. When the sun is behind the rings, they can appear almost transparent, glowing softly like frosted glass held up to a window. When the sun shines upon them from the front, they can dazzle with the brilliance of freshly fallen snow. The effect changes constantly as your imaginary spacecraft drifts, turning the entire ring system into nature's most extensive, most subtle light show. The sun's light, having traveled so far, arrives gentle and faint, yet it illuminates the ice with a pure radiance. An effect scientists call backscattering further enhances this gentle glow. When ring particles reflect sunlight directly back in the direction it came from, the rings can brighten dramatically, creating a radiant sheen that amplifies the sense of magic and spectacle surrounding Saturn. Beneath the beauty and calm, the rings reveal a fundamental truth about Saturn's magnetic and gravitational field. They are constantly being influenced. Ring brightness is not uniform. Some regions contain a subtle coating of dust or darker compounds which reduces their reflectivity. Over long periods, tiny grains of meteor dust fall into the rings from space, carrying carbon-rich molecules that slowly tint the ice. This soft coating acts like a fine layer of soot settling on a vast expanse of snow, gently dimming the original brilliance. This slow, gradual darkening hints at the long passage of time and the ring's constant, quiet evolution, the very existence of this enormous, magnificent, yet delicately fragile structure remains Saturn's first great paradox. Why do they not just spread and disappear? How does such a fleeting, airy collection maintain its majestic form? The answer is gravity, working not as a harsh, unyielding force, but as a quiet, steady hand of the cosmos, arranging every icy fragment into its ordained place. As you conclude this drift through the glittering halo, allow the sheer scale of this fragility to settle in your mind, a system so wide, yet so thin, so brilliant, yet made of the simplest ice, so seemingly solid, yet composed of countless independent pieces. It is the beginning of understanding why Saturn is a world built entirely on delicate equilibrium. In the next quiet moment, we will look beneath these gleaming fragments to understand how this magnificent structure is both sustained and, ultimately, constrained by its astonishing thinness. As you continue to float within Saturn's realm, allow the scale of the rings to fully settle in your mind, for their size is the core of their first great paradox. We've seen their delicate, glittering composition, but to appreciate their fragile grandeur, we must consider their dimensions. Imagine for a moment the sheer, unimaginable width of the main ring system. If you were to travel from the inner edge to the outer boundary of the A-ring, you would cover a distance of approximately 280,000 kilometers. That span is so vast that it would comfortably stretch across the entire space between Earth and the Moon, and then some. It is a true ribbon of ice, a graceful arc that sweeps across the darkness with immense, dazzling authority. Yet this magnificent width is accompanied by an astonishing thinness. If you could somehow measure the rings vertically from the top surface of the ice plane to the bottom, the measurement is startlingly small. The rings are, in most places, no thicker than 10 to 100 meters, the height of just a few large buildings stacked one on top of the other, or perhaps just a skyscraper. Think of the analogy from before, a sheet of paper spread across an entire football field. The contrast between their width and their thickness makes them, mathematically, almost weightless in comparison to the enormous planet they surround. They are truly a cosmic whisper, wide, delicate, and almost two-dimensional. This elegant flatness is not accidental. It is the result of those constant, gentle collisions we observed in the last quiet moment. Over billions of years, every time a particle nudges its neighbor, the slight upward or downward motion is cancelled out, coaxing the entire swarm into a shared, remarkably level plane. It is a self-smoothing system where chaos is constantly filtered into orderly serenity. As your eyes adjust, the structure of this thin, wide plane begins to reveal its elegant, layered identity. The main rings visible from afar are categorized by scientists alphabetically in the order of their discovery: the C, the B, and the A rings. Each one possesses its own character, brightness, and density. Closest to Saturn, where the faint light of the distant sun begins to filter through, is the C ring. This ring is the most transparent, often appearing ghost-like and hazy. It contains a lower density of particles compared to its neighbors, allowing you to see Saturn's cloud top softly through its structure. It is the subtle beginning of the system, a soft veil drawn close to the massive planet. Moving outward, you encounter the B ring. This is the brightest and densest of all. Here, the particles are so numerous and so tightly grouped that the B ring reflects sunlight with incredible efficiency, shining like a massive, beautifully frosted mirror. From afar, it is the B ring that gives Saturn its dazzling, eye-catching appearance. Its density creates a substantial band of light, holding the greatest mass and intensity of the entire system. Beyond the B ring, sweeping elegantly into the darkness, is the A ring. Broader than the B ring and slightly more translucent, the A ring is still vividly bright enough to catch the eye. It forms the graceful outer boundary of the main system, where the icy material begins to thin out, marking the final major arc of visible ice before the gaps and fainter rings begin. But the rings are not merely three continuous bands. They are separated by spaces, gaps carved by the subtle hand of gravity. The most significant of these is the wide, dark space separating the A and B rings known as the Cassini division. This division is not entirely empty, but it is sparse enough in icy fragments to appear as a deep, dark breath between the two brightest brushstrokes of ice. It is a boundary, a place where the flow of the ice is interrupted, almost like a path worn into a field of snow. The Cassini division is one of Saturn's early scientific puzzles, revealing the power of invisible forces. It is maintained not by a distant boundary, but by the gravitational influence of one of Saturn's small, ice-covered moons, Mimas, which orbits far outside the division itself. Mimas and the particles in this region share a rhythmic relationship known as a resonance, a gravitational beat that, over millions of years, has gently nudged the particles away, creating and maintaining the wide, cleared space we see today. Beyond these major structures, the C, the B, the A, and the wide Cassini gap, there are even more subtle ringlets, wispy strands and fainter halos. These reveal themselves only when curiosity draws you deeper, or when sunlight catches them at just the right angle. For now, these three major bands and their primary division offer a gentle glimpse into the exquisite, structured chaos of Saturn's icy adornment without overwhelming the senses. They demonstrate that while the rings are a swarm of individual particles, they are not random. They are a highly organized, hierarchical system shaped by density, light, and the unseen mathematics of gravity as you hover here, looking down upon the softly patterned cloud tops through the faint sea ring and observing the sheer, impossible thinness of the brilliant B ring. You realize that this feature that makes Saturn famous is the ultimate paradox of fragility. It is a vast, beautiful structure that owes its endurance not to rigidity, but to motion and quiet balance. The immense size and delicate nature of the rings raise the obvious question: what kind of planet wears such a fragile, magnificent adornment? To understand the rings' endurance, we must next turn our attention to the planet that anchors them. For Saturn itself is home to an even more surprising contradiction, that of being both a massive giant and one of the solar system's lightest worlds. We have gazed upon the delicate, immense fragility of the rings. Now it is time to turn our attention to the planet that anchors this magnificent structure, for Saturn itself holds a contradiction even more profound than its icy crown. This is its buoyancy paradox. If you have spent any time around space enthusiasts or simply read popular science facts, you may have heard a rather whimsical claim that Saturn is so light it could float on water. It is an image that tends to stick in the mind, a giant planetary rubber duck bobbing cheerfully in a cosmic bathtub. It's a charming thought, but like many playful space facts, it needs a gentle unraveling before it drifts too far from reality. The core of this idea comes from Saturn's average density. When scientists speak of density, they are referring to how much mass is packed into a certain amount of space. Saturn's density is surprisingly low, so low in fact that it is lower than that of liquid water. If you were to compare them in simple terms, the material that makes up Saturn, on average, weighs less than the same volume of liquid water. So, in theory, if you could find a body of water large enough, Saturn would indeed float. However, the practical difficulties with this mental picture arrive quickly and with some gentle humor. For one, there is no bathtub in the universe quite capable of accommodating a planet with a diameter of over 120,000 kilometers. And even if there were, Saturn would not stay politely intact as it drifted across the surface. Being a gas giant, it has no solid shell to sit upon the water. Instead, the enormous gravitational forces would likely distort the hypothetical bathtub long before Saturn had a chance to show off its buoyancy. The floating Saturn idea is a delightful mental picture, but the reality beneath it is far more interesting. Saturn is composed mainly of the two lightest elements in the entire universe, hydrogen and helium. These are the same elements that also make up the Sun and most of the stars we see twinkling in the night sky. On Earth we are familiar with hydrogen and helium in their airy, gaseous forms. Helium is what fills party balloons, and hydrogen is an essential reactive element. Imagine a world made primarily of these airy, weightless ingredients, and you begin to understand why Saturn ended up with such a low density. Yet, low density does not mean weak or hollow, nor does it mean Saturn is somehow fragile. Saturn is still absolutely enormous. If our Earth were the size of a cherry tomato, Saturn would be a massive beach ball beside it. Even though it is made from the universe's lightest material, the sheer volume of the planet means it holds a tremendous amount of mass. In fact, Saturn is over 95 times more massive than Earth. That is a staggering thought. A planet made mostly of the lightest ingredients, yet still possessing a kind of presence and weight that Earth, small and dense, could never compete with. To better grasp this contrast, light materials yet immense mass, imagine holding two objects in your hands. On one hand, a large, fluffy marshmallow. In another, a small bowling ball. The marshmallow is far bigger, easier to compress, and full of air. The bowling ball is tiny by comparison, but surprisingly heavy and dense. Saturn is the marshmallow in this analogy, huge but made of light materials. Earth, on the other hand, is the bowling ball, smaller but packed tight with heavy elements like iron, oxygen, and silicon. So, although Saturn has a lower average density, the sheer size of the planet ensures that gravity still holds a firm grip. When we talk about gravity on Saturn, it helps to reflect on what gravity truly is. Gravity is not about how light or fluffy something feels. It is about how much mass there is. Saturn has a huge mass, so its gravity is strong. If you were to somehow stand on a cloud top, the pull of gravity would feel slightly stronger than it does on Earth. This might come as a surprise when you hear that Saturn's density is so low, but this is one of the first and most elegant paradoxes Saturn offers. It is deceptively light in composition, yet remarkably powerful in its gravitational pull. The idea of a planet made of such lightweight ingredients, yet capable of shaping an entire miniature solar system, is part of Saturn's quiet charm. It captures the imagination because it defies the instinctive expectation that big should always mean heavy, and that light should always mean weak. Saturn sits beautifully in the middle, being both. It is light in substance, yet heavy-handed in its influence. It floats in theory, yet anchors dozens of moons, an intricate system of rings and space itself. In reality, Saturn invites us to let go of our earthly assumptions and gently rethink what words like light, heavy, strong, and delicate truly mean when applied to a cosmic scale. Saturn, despite being composed mostly of hydrogen and helium, is undeniably mighty. Its gravity shapes orbits, sculpts rings, and governs a family of moons like a patient conductor guiding a cosmic orchestra. And it does all this while being one of the least dense worlds in our planetary neighborhood. It is a planet that appears soft and airy on paper, yet in space it holds ultimate authority. Light in substance, immense in scale, graceful in form, and influential in ways that are felt far beyond its cloud tops, Saturn embodies a paradox that makes it one of the most intriguing of all the planets. As you allow this contradiction to settle, the enormous size, the airy composition, the powerful pull, you are ready to explore the hidden layers beneath the clouds that give this buoyant giant its distinctive identity. Having grasped the paradoxical lightness and immense size of Saturn, we now turn our gaze inward, gently descending through the pastel cloud tops to explore the profound internal structure of this gas giant. Beneath the serene appearance of the planet lies a world entirely defined by gradual, crushing change, a transition from airy gas to something resembling a liquid metal. Saturn's interior is layered a bit like a vast, impossibly large onion, made not of rings of vegetable, but of gas and liquid, compressed by the weight of the material above it. The outermost part of the planet, where we have been observing the gentle stripes, is a deep atmosphere rich in hydrogen and helium. This is where the journey begins, a place of swirling winds and low-density gas. As you descend deeper, the pressure begins to build, steadily, relentlessly. The gases become thicker and denser, packed together by the colossal weight of the atmosphere above. The environment gradually transitions into liquid-like states where hydrogen, though not truly liquid, in the way water is on Earth, behaves like a highly dense, hot fluid under immense pressure. There is no sharp boundary here. The change is slow, continuous, and overwhelming. Deep still, scientists believe there is a layer of metallic hydrogen. This is a strange, shimmering, almost unimaginable form of hydrogen that behaves like a metal due to the crushing pressures that exist at that depth, pressures millions of times greater than those found on Earth's surface. In this state, electrons are stripped from hydrogen nuclei, allowing the material to conduct electricity freely. It is the movement and swirling of this vast ocean of metallic hydrogen that is thought to generate Saturn's powerful and mysterious magnetic field, which extends far out into space. Beneath this strange, shimmering metallic layer lies the core. This center is thought to be composed of heavier materials, perhaps rock, metal, and ice, mixed into a dense, superheated center. We cannot visit this core, nor could any probe land there. The combined pressure and heat would instantly destroy any spacecraft long before it reached that depth. But through scientific models and measurements, we can picture this dense heart with reasonable confidence, resting beneath its oceanic layers of gas and compressed liquid. The crucial difference between this world and our own is the absence of a solid surface. You could not stand on Saturn as you can on Earth or Mars. If you were to drop through Saturn's clouds, you would pass through gas that becomes steadily thicker until it transitions into a liquid. There is no ground to meet, only increasing density and a mounting weight that would eventually end any journey. Saturn is a world defined entirely by gradual change, from gentle breezes at the top to crushing weight at the bottom. One of the reasons Saturn maintains such a distinct, yet slightly unusual shape is its rapid rotation. Saturn spins on its axis very quickly, completing a full rotation in just over 10 Earth hours. That is remarkably fast for a planet of its size, and this speed, combined with its fluid, gaseous nature, has sculpted its form. This rapid spinning causes Saturn to bulge outward around its middle, resulting in a shape known as an oblate spheroid. In simple terms, Saturn is noticeably wider at the equator than it is from pole to pole. This bulging effect is a common result of rapid rotation. Earth experiences it too, though to a far lesser degree. On Saturn, the effect is pronounced because it is made of vast, fluid layers that are easily stretched by the speed of the spin. Imagine a soft ball of dough being spun quickly on a baker's fingertips. It would stretch and flatten at the poles as it rotates. The planet's equator becomes its widest point, giving Saturn a slightly squashed, flattened appearance when viewed in profile. This subtle distortion is an external clue to the tremendous unseen forces acting inside the planet. The rapid spin contributes not only to its shape, but to the constant, fast-flowing energy within its atmosphere, creating the strong jet streams that form the beautiful, gentle bands of color we see across its surface. The Saturn paradox is fully realized inside. We descend from a light, airy atmosphere into a region of impossible pressures and metallic fluidity. This is a powerful, deep-seated engine driven by motion and weight that holds the planet together and generates its unseen magnetic shield. It is a world where lightness and mass, speed and structure coexist in a state of continuous interior harmony. The internal quiet of its magnetic field and the soft, steady flow of its interior ensure that this gentle giant continues its timeless journey around the distant sun. Now that we have gently touched upon the deep structure of the planet, we will surface once more to explore the visible layers, examining the fast, flowing nature of the atmosphere itself, a surface of wind and color that seems to sing even in the vacuum of space. Having briefly descended into the high-pressure depths of the buoyant giant, we gently rise back toward the planet's surface, or rather its cloud tops, to explore the atmosphere that serves as the boundary between the inner planet and the vacuum of space. As you hover gently above Saturn's curved surface, the first thing you might notice is how soothingly patterned the planet appears. Soft bands of color wrap horizontally around its immense circumference, forming pale, continuous stripes of cream, butterscotch, and muted gray. These bands encircle the entire planet, stretching all the way around like the long, careful brush strokes of a master painter working only in calm, horizontal lines. From this distance, the effect is profoundly peaceful, almost dreamlike, as though Saturn is dressed in layers of softly woven silk. This tranquil appearance is what gives Saturn its characteristic air of serenity among the more turbulent-looking giants. Yet beneath this calm visual surface lies an atmosphere full of extraordinary motion. Saturn is, in reality, a world of winds, fast, flowing, and intricately organized. These winds move around the planet in long, continuous ribbons known as jet streams. They travel mostly parallel to the equator, alternating their direction, some flowing from west to east, others from east to west, creating a finely striped pattern where the streams meet and interact. This system of fast-flowing air means that Saturn is, in essence, an atmospheric engine, constantly converting internal heat and rotation into kinetic energy. And the speed of this engine is astonishing. The wind speeds on Saturn can reach truly impressive levels, racing along at over 1,000 kilometers per hour near the equator. To put that speed into perspective, consider the most catastrophic storms on Earth, which might feature winds a tenth of that velocity. On Saturn, winds this strong are not an extreme event. They are simply part of the planet's daily, quiet rhythm. They flow with such consistency and uniformity that, paradoxically, they create the very pattern of peace we observe. One of the main reasons Saturn's atmosphere is so dynamic, yet so elegantly patterned, is the intense speed of the planet's rotation. As we discussed when exploring its inner layers, Saturn completes a full spin on its axis in just a little over 10 Earth hours. That is remarkably fast for a world so vast. To visualize this, imagine taking Earth, which takes 24 hours to turn once, and spinning it more than twice as fast. The changes to our weather systems would be dramatic. Saturn, being much larger and spinning so swiftly, experiences tremendous forces in its atmosphere. This rapid rotation causes something known as the Coriolis effect, which influences how winds move, forcing them to bend and organize into defined east-west flows. On Earth, this effect shapes hurricanes and trade winds. On Saturn, it amplifies that organizational motion across a far bigger canvas, creating multiple jet streams and the beautifully banded weather systems that span the entire planet. The atmosphere essentially organizes itself into sweeping, structured flows rather than chaotic clashes. These gentle bands of color that we see from afar are not painted onto a solid surface. They are the visible result of different wind speeds, temperatures, and cloud compositions at varying depths of the atmosphere. Each visible stripe has its own character, influenced by the complex behavior of the gases swirling beneath. While Jupiter often presents itself as a turbulent oil painting, filled with dramatic swirls and aggressive spots. Saturn is more like a softly blended watercolor, where edges melt gently into one another. The appearance is quieter, more subdued, but no less captivating. Everything moves with a kind of innate grace, where even the fastest jet stream seems to glide rather than roar. If you could float alongside these winds, you would not hear a sound. There would be no audible roar or howl of the wind rushing past, only movement. The cloud bands would flow past like the slow unfurling of silk ribbons in a soft, steady current. It is this paradox of sensation, incredible speed paired with total quiet, that contributes to the feeling of Saturn being a place of serene, profound power. Everything is exaggerated in scale, the size, the winds, the speed, yet everything moves with a quiet elegance. This elegant motion is part of the planet's self-regulating mechanism. Scientists often describe Saturn as a finely tuned system, converting the energy from its quick rotation and the faint, distant sunlight into flowing currents that can last for decades, maintaining the same smooth patterns year after year. It is a reminder that calm appearances can hide endless, highly organized activity beneath the surface. In the deepest quiet of your focus, allow the image of this great planet to settle, a vast sphere of airy material, quietly spinning at immense speed, its atmosphere a constant, complex flow that presents itself to the cosmos as nothing more than a series of soft, perfectly aligned ribbons. It is the very definition of a serene engine, humming softly, endlessly, in the distant dark. The gentle rhythm of the atmosphere now commands our full attention. We have established that Saturn's immense, striped surface, for all its visual tranquility, is an arena of incredible, silent speed. The key to understanding this paradox, the appearance of quiet calm over an environment moving at over 1,000 kilometers per hour, lies in the physics of rotation and the precise arrangement of its chemical layers. Imagine Saturn spinning like a colossal gyroscope, completing its rapid turn every 10 hours. This immense, rapid rotation acts as the planet's silent conductor, orchestrating every wisp of gas and every moving current into a highly organized pattern. This force is the Coriolis effect, the powerful, unseen hand that dictates the flow of any large body of fluid on a rotating sphere. On Saturn, the Coriolis effect is dramatically amplified by the planet's size and speed, preventing the winds from blowing in chaotic spirals. Instead, it forces all the massive air movements into those distinct, stable east-west bands we observed. These are the zonal flows, the great jet streams that run parallel to the equator. Every cloud, every ripple is compelled to follow these lanes, creating a system where flow is mandatory and turbulence is minimized, resulting in that deceptive, smooth appearance. It is a powerful reminder that on a planetary scale, great speed often leads not to chaos, but to magnificent, lasting order. The elegance of the atmosphere is not just in its movement, but also in its substance. The colors and textures we observe, the gentle creams, the soft golds, the muted yellows, are created by clouds layered deep within the vast hydrogen and helium envelope. Unlike the air we breathe, Saturn's atmosphere does not have a single, continuous cloud deck. Instead, it is divided into distinct chemical layers, each forming clouds at different depths, where the temperature and pressure are just right for condensation. At the very top, in the coldest, outermost regions, are the clouds made primarily of ammonia ice. This layer often appears wispy and white, but it is constantly buffeted by the high-speed jet streams, which stretch and thin the cloud material into those characteristic long stripes. Beneath the ammonia clouds, where temperatures are slightly warmer due to the rising internal heat of the planet, lies a layer of ammonium hydrosulfide ice. It is this layer that is believed to contribute much of the subtle yellow and orange hues we associate with Saturn's color palette. The chemical reactions that occur here, influenced by sunlight, gently stain the ice particles, adding quiet color to the sweeping bands, and deeper still, at the deepest observable levels where the temperatures are warm enough, scientists predict a layer of water ice clouds, the same basic material that forms clouds on Earth. This water vapor, however, is hidden beneath the immense, compressed layers of gas above it. This layered structure explains the planet's muted palette compared to its sibling, Jupiter. Jupiter displays vivid, tumultuous reds, oranges, and deep browns because its chemical layers are more directly visible. Saturn, however, is veiled. The colorful clouds of ammonia, hydrosulfide, and water ice are masked by a persistent, high-altitude haze of molecular hydrogen that diffuses the sunlight and blurs the colors beneath. It is like looking at a vibrant painting through a very thin, slightly translucent curtain. The colors are there, the motion is there, but everything is softened, creating that pervasive sense of serenity that defines Saturn's presence. This blurring, this gentle filtering of light and color, enhances the feeling of a world held in perfect, calming suspension. The sheer size of the cloud bands is also mesmerizing. Each zonal flow, each quiet stripe of color, is a river of wind that can be thousands or even tens of thousands of kilometers wide, stretching its immense length around the entire planetary sphere. When you view them, you are observing not merely weather systems, but planetary-scale flows that have remained remarkably stable for decades, possibly centuries, their boundaries defined by the Coriolis forces and their color supplied by the slow, steady chemistry of the depths. This symphony of speed is performed without a sound, driven by the planet's internal forces and sculpted by its furious rotation, yet presenting a face to the cosmos that is the very definition of a calm, immense powerhouse. It is the ultimate expression of the rule that in the grand physics of the cosmos, organization often emerges from the most extreme conditions. The planet is in constant high-speed motion, yet it appears perpetually at rest. We have now explored the paradoxical fragility of the rings, the mysterious buoyancy of the giant, and the elegant, layered motion of its atmosphere. But Saturn is not alone. It is a true ruler commanding a vast and diverse family of dozens of moons. These tiny worlds, each with its own strange identity, orbit within and around the rings, acting as shepherds, sculptors, and timekeepers for the entire system. In the quiet moments ahead, we will drift away from the central planet and turn our attention to the silent, icy children of this enigmatic giant. Despite the calm, blended appearance of Saturn's banded atmosphere, it remains a vast ocean of gas, and like any such fluid system, it is home to periods of powerful yet strangely graceful turbulence. We turn now to observe the moments when this serenity is briefly, majestically broken by the quiet tempest, storms that can grow to truly impressive, continental sizes. Saturn is no stranger to tempests that stretch across thousands of kilometers, sometimes coiling and wrapping around the entire planet in colossal bands of cloud. These storms can last for months or even years, gradually shifting shape as they travel along the fast-flowing jet streams. They are not chaotic outbursts, but rather periods of intense, organized energy that temporarily punctuate the planet's otherwise steady rhythm. One particularly famous type is the Great White Spot, a recurring storm system that appears roughly once every Saturnian year. To us on Earth, that seems like a long wait between storms, as a single orbit of Saturn takes about 29 frac, or $1-2 Earth years. But for Saturn, it is simply part of a deep, seasonal rhythm. When these enormous storms emerge, they can be a spectacular sight, towering plumes of bright cloud that rise high above the surrounding, muted atmosphere. They can be seen even from telescopes here on Earth as large, brilliant smudges of light against Saturn's normally soft, pale palette. Inside these storms, the forces at work are immense. The sheer scale and speed of the atmosphere cause electrical activity that dwarfs what we experience at home. Lightning flashes within Saturn's tempests with a force that can be hundreds of times stronger than a typical lightning bolt in our sky. Because Saturn's atmosphere is thick and composed of different materials under high pressure, this lightning behaves differently, illuminating the clouds and glowing through the hazy layers, making the storm appear to pulse briefly with internal light. Yet, here is the profound paradox. Despite this immense power and dramatic electrical discharge, these storms unfold in absolute silence. If you were to float near the cloud tops of a great white spot, you would see the churning, the bright flash of the lightning, and the vast circulation of the clouds, but you would hear nothing. The movement is visible, not audible. The dense gas currents and the colossal electrical bolts happen within the vacuum of space, preventing the propagation of sound waves. The atmosphere roars only in terms of velocity and energy, not acoustics. This transforms the most dramatic weather system into a silent spectacle, a quiet tempest that illustrates the strange rules of the outer solar system. The vast majority of Saturn's weather patterns, despite the incredible wind speeds, are actually steady and elegantly structured. The atmosphere tends to organize itself into those sweeping flows rather than chaotic clashes. The storms that do form often become part of the planet's larger atmospheric tapestry rather than tearing it apart. Saturn's winds, despite their speed, have a kind of rhythm to them, a sense of cooperation rather than conflict. They sweep across the planet in long, uninterrupted bands, sometimes merging, sometimes separating, but always maintaining that soft, banded appearance for which Saturn is known. Because of this constant, rapid rotation and the layered clouds, the colors we see on Saturn remain subtle. There are no deep, vibrant reds or bright oranges like those sometimes seen on Jupiter. Instead, Saturn wears the softer shades of sunrise, pale golds, gentle creams, light grays, and occasional hints of muted pearl. These colors shift over time as atmospheric conditions change, but the overall effect remains one of quiet elegance. It is as if Saturn has chosen a calmer wardrobe, one suited for a planet that prefers to whisper rather than shout. This world teaches us that calm appearances can hide endless activity. When we think of wind on Earth, we often imagine a gentle breeze or perhaps a stormy gust that bends trees. On Saturn, the winds we speak of are movements of gas and cloud gliding and streaming through a vast, surfaceless atmosphere. If you could ride along with one of these flows, you would experience the motion but only see the silent, slow unfurling of the cloud bands passing you by. It is this profound juxtaposition, incredible speed paired with total quiet, immense power veiled by soft color, that contributes so deeply to the feeling of Saturn being a place of serene power. Even the most dramatic tempests become part of a greater harmony, turning the whole planet into a kind of cosmic orchestra where each current of gas plays its part in maintaining the balance. Winds that sing, clouds that dance, and silent lightning that briefly illuminates the darkness. Saturn is, in its own way, a world of music without sound. Now, as your imagination continues its gentle drift, allow the immense scale and the hushed nature of this weather to settle. In the next quiet moment, we will explore the most unique and geometrically precise feature of Saturn's atmosphere, a storm system so perfectly shaped that for years it defied all expectations of natural order. Near Saturn's North Pole, there is a sight so unexpected, so breathtaking in its precision, that for many years it left both astronomers and casual sky watchers blinking in quiet disbelief. It is a storm system shaped not like a simple circle or a turbulent spiral, but like a six-sided figure, a vast, swirling hexagon, neatly formed as though drawn with the help of a cosmic ruler. Gentle in color, yet striking in its shape, This atmospheric pattern has become one of Saturn's most iconic mysteries, the planet's geometric crown. Imagine flying above Saturn's North Pole and seeing this shape below you. 6 smooth sides, each stretching thousands of miles long, meeting at crisp, deliberate angles. The hexagon rotates slowly with the planet, maintaining its flawless form year after year, behaving with a kind of serene stubbornness. Most storms and atmospheric flows in our solar system twist into circles or ovals because that is the most natural shape for rotating fluids. Yet, here at the top of Saturn, nature has done something beautifully unusual. It has folded movement into perfect symmetry. When the hexagon was first captured in images during the early 1980s by the Voyager spacecraft, many people wondered whether it could possibly be real. It was so precise, so unlike anything ever seen on another planet, that initial reactions leaned toward suspicion. Was it a trick of the camera, a processing artifact, or, as some more imaginative thinkers mused, a structure that could not possibly occur without an otherworldly architect? Fortunately, as clearer images and more advanced observations arrived decades later, the answer became far more grounded and, ultimately, far more fascinating. The hexagon is not an artificial creation or a visual mistake. It is a natural phenomenon, a profound product of physics and fluid dynamics shaped by the extreme motion of Saturn's atmosphere. To understand how such a rigid shape can form in a fluid, swirling gas, it helps to think about waves. Not the kind you find on the sea, but waves in any fluid, including the vast gases of an atmosphere. When a fluid spins around an axis, its motion can settle into organized patterns. On Saturn, a powerful and steady jet of air flows in a huge curved stream around the North Pole. Rather than circling in a smooth, continuous ring, this jet stream develops into a standing wave pattern. A standing wave is a wave that appears to stay in one place, even though the movement within it continues relentlessly. You may have seen a simple version of this if you've ever gently shaken a long rope or a skipping rope just right. It forms a steady, wiggling pattern that seems to hold its shape even as the rope moves. Now, imagine that flow wrapped into a complete circle, and imagine the wave creating peaks and troughs around the loop. Depending on the exact conditions, speed and viscosity, that circular wave can settle into a structure with 2, 3, 4, 5 or more sections. On Saturn, the atmosphere has chosen 6. This standing wave, shaped and stabilized by the rapid rotation and the sheer scale of the jet stream, forms the hexagon. Laboratory experiments have successfully reproduced polygon-shaped currents on a smaller scale, confirming that nature can indeed create shapes with corners in rotating fluids. Given the precise conditions, crucially, the hexagon is not a flat painted pattern on the surface. It has height. It extends deep into Saturn's atmosphere, towering vertically like a slowly turning chimney of weather. Each side of the hexagon is a section of this powerful current, and together they form the complete, stable polygon. Most storms on giant planets are turbulent, chaotic, and short-lived compared to the scale of their host worlds. The Great Red Spot on Jupiter is a famous, long-lasting exception, but even that swirling oval changes shape over the decades. Saturn's hexagon, however, holds its structure with remarkable loyalty. It maintains its shape through years, through full Saturnian seasons, and across the decades. It behaves like a patient, geometric clock turning with the planet, adjusting subtly but never abandoning its six-sided identity. The stability of this unusual shape lies in the perfect balance between Saturn's rotation, the immense speed of the jet stream, and the layering of the atmosphere. The jet stream at the hexagon's latitude is fast enough and consistent enough to maintain the standing wave. Small variations in speed, temperature, or density that would break such a pattern elsewhere are here aligned in a harmonious, stable way. The atmosphere flows, waves form, and the geometry quietly locks in. The hexagon is a wonderful example of nature surprising us with a level of complexity that we might not have dreamed possible. It is a reminder that physics can produce beauty that rivals any human design without needing any guiding hand. It is simply the universe showing off its love of pattern. So the next time the thought crosses your mind that nature prefers randomness, remember Saturn's North Pole. Up there, beneath the pale sunlight of a distant star, a six-sided storm turns unhurried and unwavering. It is a peaceful hexagon shaped by nothing more than the physics of flowing gas, reminding us that order can rise out of turbulence, and that even where winds roar at astonishing speeds, there can be structure, steady, elegant, and wonderfully strange. In the next quiet moment, we will explore how this immense, slow-turning world experiences time, drifting into the deep perspective of Saturn's long and patient seasons. On Earth, the changing seasons feel familiar and reassuring. Spring warms into summer, autumn cools into winter, and the full journey through all 4 seasons takes one Earth year, a rhythm so natural that we often measure our lives by it. Saturn, however, keeps a far, far slower calendar. In the depths of the outer solar system, time itself stretches, leading to the profound perspective of decades of dawn. A single year on Saturn, one full orbit around the distant Sun, takes nearly 29 $2 Earth years. That vast span means that each individual season on the ringed giant lasts for more than 7 Earth years. Imagine winter lingering for almost a decade, or summer stretching so long that children born at the beginning of the season would be well into their middle childhood before the next season arrived. On Saturn, the seasons unfold like a slow-motion ballet, too gradual to witness in a single human glance, yet majestic when viewed across immense spans of time. Just like Earth, Saturn has seasons because it is tilted on its axis. Saturn leans at an angle of roughly 26 to 27 degrees, very similar to Earth's tilt of about 23 (1·2) degrees. This similarity in tilt means that as Saturn travels along its long, slow orbit, different parts of the planet receive more or less sunlight. The tilt ensures that sometimes the northern hemisphere leans toward the sun, bathing it in extended daylight, and at other times the southern hemisphere enjoys that warmth instead. Between these two extremes come more balanced periods where neither hemisphere is favored. Although the mechanism is similar to our own, the scale and pacing of these seasonal shifts are vastly different. If you could hover near Saturn long enough to watch a full Saturnian year unfold, you would notice that the planet's appearance gently changes as the seasons progress. One of the most striking seasonal effects can be seen not in the atmosphere alone, but in the mesmerizing behavior of the rings and the shadows they cast. Saturn's rings are not simply ornaments circling the planet. They interact intimately with the sunlight, creating incredible visual effects that change throughout the long year. Because the rings are wide and incredibly thin, they cast long, sweeping shadows across the cloud tops. These shadows behave like soft brush strokes that shift, lengthen, fade, and reappear as the angle of sunlight changes. During Saturn's solstices, when one hemisphere is tilted most strongly toward the sun, the shadows of the rings stretch dramatically across the planet. Imagine watching dusk slowly crawl over a landscape, except here the landscape is a vast gaseous world, and the shadows are drawn not by mountains or trees, but by the rings of icy debris suspended high above. At one solstice, Saturn's northern hemisphere is bathed in years-long periods of sunlight, while the southern hemisphere sits in an extended twilight. Half a Saturnian year later, many Earth years after, the opposite occurs. Because of the sheer length of these seasons, the concept of a sunrise or sunset takes on an entirely different patient meaning. A single Saturn spring lasts about 7 Earth years. Dawn does not sweep quickly across the land, it creeps. The slow increase in light creates what could be described as a decades-long morning. A sunrise stretched so thin across time it becomes almost impossible to perceive in real time. If you were a Saturnian cloud, you might experience sunlight gradually brightening over the course of several Earth years. Spring would feel like a slow inhalation of warmth. Summer would be a long, steady glow. Then there are the equinoxes, special moments that occur twice every Saturnian year, separated by nearly 15 Earth years. During an equinox, Saturn's tilt aligns in such a way that sunlight strikes the rings edge-on. Because the rings are so extraordinarily thin, this edge-on view makes them appear almost invisible when viewed from certain angles. At these times, the rings cast almost no shadow on Saturn's surface. The great sweeping strokes of darkness that appear at other times vanish, and the planet's cloud tops glow more evenly. For a brief period, a brief Saturnian period that is, the planet wears no ring-shaped shadows at all. This slow, patient rhythm gives Saturn a sense of profound calm. Nothing rushes. Change flows like syrup rather than water, thick and leisurely. The sunlight that falls on Saturn comes from a great distance, appearing smaller in the sky than it does from Earth, and the warmth arrives with a softness. No sudden bursts of heat or sharp drops of temperature interrupt the rhythm. Instead, the seasons change like turning a page in a very slow, very ancient book. There is something soothing about a world where dawn lasts for years, where summer is a long exhale, and where winter is not a fleeting phase, but a deep slumber of the hemisphere. Saturn, as a whole, feels like a planet built for dreamers, a place where nature refuses to be rushed. If Earth's seasons remind us of renewal and quick cycles of life, Saturn's remind us of patience and the quiet beauty of time measured in long, sustained breaths rather than quick, sharp moments. As you picture Saturn turning slowly through space, its rings shifting gently as the sunlight changes, you may begin to feel the quiet inspiration that such a rhythm provides. Long before Saturn shone as the golden jewel of our solar system, long before its rings formed their icy lace, and long before any moons gathered around it, there was only a cloud. Not a delicate cloud like those drifting across Earth's sky, but a vast, swirling disk of gas and dust surrounding a newborn sun. The early solar system was a place of gentle chaos, warm, hazy, and full of drifting material, illuminated by the faint glow of a young star that had only recently ignited into life. This environment is what scientists call a protoplanetary disk. Within this immense disk, every planet, moon, asteroid, and comet began as something unimaginably small. The story of Saturn's birth starts with dust. That may sound humble for a world that would one day be wrapped in rings and cloaked in clouds, but dust is where nearly all planets begin. At first, the disk contained tiny grains, fragments smaller than a grain of sand, made mostly of elements like silicon, carbon, and frozen water. They drifted together in the faint turbulence of the young solar system, colliding gently. When these particles touched, static forces helped them cling to one another, much like flour slowly clumping when stirred in still air. Over immense periods of time, these grains stuck and slowly grew into larger pieces, first into small clumps, then into pebbles, and eventually into rocks. The journey from dust to something substantial was slow but steady. As these small pieces grew, they formed what astronomers call planetesimals, objects large enough that gravity began to play a significant role. Once gravity enters the picture, growth accelerates. Gravity acts like a quiet invitation, drawing in more material, coaxing nearby objects to come closer. A planetesimal with even a little more mass than its neighbors gains a profound advantage, because it can gather material far more effectively. To become a gas giant like Saturn, however, a forming planet needs more than just rock and ice. It must grow large enough, quickly enough to capture the enormous amount of gas from the protoplanetary disk before that gas disappears. This is crucial because the disk itself doesn't last forever. Young stars blow a material away through radiation and stellar winds, clearing the disk within a few million years. This was Saturn's ticking clock. To capture gas in the large quantities we see today, a world needs a massive, solid core first, something with enough mass to attract the hydrogen and helium, the lightest and most abundant elements in the disk. This process is known as core accretion. In Saturn's case, the core likely formed from rock and ice until it reached a mass several times larger than that of Earth. Once that happened, its gravity became strong enough to draw in the surrounding gas like a magnet. Imagine a snowball rolling downhill, gathering more snow as it moves and growing faster with each turn. Saturn's core did something similar, only with gas instead of snow. Hydrogen and helium streamed toward the growing world, enveloping the core in thick, rapidly expanding layers of atmosphere. In this way, Saturn transformed from a frozen seed of dust and ice into a majestic world of gas wrapped around a dense center. Once Saturn formed, its story was far from over, for where a planet is born is not always where it stays. Planets can and do migrate. They don't glide freely like balloons, but gravitational interactions can nudge them from their birthplaces. Looking at Saturn today does not guarantee that this was always its home. Many astronomers now believe that the giant planets, Jupiter, Saturn, Uranus, and Neptune, may have been born closer together than where they currently reside. Early models suggest that gravitational interactions, particularly between Jupiter and Saturn, played a key role in a dramatic event known as the Grand Tack. The two giants influenced each other's movements like massive dancers adjusting their steps to avoid clashing. As they interacted, their orbits changed, reshaping the entire architecture of the solar system around them. Some models propose that this migration even helped sculpt the inner solar system, influencing the distribution of material that contributed to the formation of worlds like Earth and Mars. Saturn, in this sense, was not just passively finding its place. It was an active participant in shaping the cosmic neighborhood we know today. Over time, as the protoplanetary disk dissipated and the giants settled into more stable orbits, Saturn found itself in the region it still occupies now, far from the Sun. At this distance, sunlight is faint and temperatures are low. These conditions helped Saturn retain its thick atmosphere of hydrogen and helium, preserving the identity it developed during formation. In many ways, Saturn's current location allowed it to flourish as a gas giant. It is far enough from the Sun that its vast layers of gas remain cold and bound, yet close enough that sunlight can still touch its clouds and illuminate its rings. Its journey from a tiny grain of dust to a massive, orbiting ruler is a lesson written into the fabric of the solar system, that time, patience, and the gentle pull of gravity can transform the simplest beginnings into something truly extraordinary and enduring. As we return our attention to the magnificent rings, we move from the story of Saturn's grand birth to the infinitely smaller, yet equally profound details of its icy crown. The rings, which stretch so wide and yet remain so impossibly thin, are not a single continuous band but a colossal, moving mosaic. The icy tapestry woven from billions upon billions of individual fragments. To truly appreciate this tapestry, we must understand the threads from which it is spun. The rings are composed almost entirely of water ice. In many places, this ice is remarkably pure, which is the primary reason for the ring's bright, dazzling reflective quality. When the faint, distant sunlight strikes the countless icy surfaces, it bounces off with great efficiency, giving the rings their legendary brilliant sheen. Along with the pure water ice, the rings contain small amounts of dust and darker organic molecules, adding subtle touches of color and chemical complexity to the overall design. the particles themselves move through the rings in a state of organized harmony. Each particle orbits Saturn at its own precise speed, a speed dictated by its distance from the planet. Inner particles closer to Saturn travel faster, maintaining their lead in the grand celestial race. Outer particles move more slowly. This difference in speed is crucial. It means that the particles do not all move as one rigid sheet, but rather as an infinite set of layered flows, with faster and slower lanes swirling together without great disruption. The result is a system that appears perfectly smooth when viewed from afar, yet is full of constant, coordinated movement when seen up close. Despite this calm, organized flow, gentle collisions occur constantly. Particles nudge into each other, transferring small amounts of energy and momentum. Unlike collisions on Earth, which can be sudden and violent, these impacts are more like the soft, repetitive tapping of snowflakes settling together. Space has a way of slowing and softening all interactions. Over immense spans of time, these countless small encounters help to keep the entire structure thin and flat, correcting any particle that strays too far above or below the plane. These interactions act as a quiet, unseen sculptor, maintaining the ring's elegant shape without any need for external intervention. These gentle collisions also work to smooth out irregularities. If a cluster of particles clumps too closely, small impacts can gradually disperse them. Conversely, if particles spread too far apart, the subtle, localized gravitational attraction between the clumps can draw them back together. This balance between clumping and separation creates what might be called ring weather, subtle patterns that change over time. Some patches of the rings thicken temporarily, forming bright, denser streaks known as wakes or clumps. These small, localized disturbances drift and dissolve, forming and reforming as the particles continue their endless, silent dance. Though the rings appear almost perfectly flat, there are also tiny ripples and bends within them. These features can emerge when something disturbs the orbits of the ring particles, perhaps a passing moonlet or a slight nudge from a force embedded within the ring itself. From certain angles, these ripples can cast slender shadows, revealing the subtle, three-dimensional nature of what otherwise appears to be a level surface. How the rings interact with light is a study in itself. The rings can adopt different moods depending on the sun's position. When sunlight hits the rings directly from behind, they may appear almost transparent, and their shadows fall upon Saturn in sweeping, curved arcs. When the sun sits in a different position, those shadows can vanish, and the rings glow like silver threads drawn across the darkness. The brilliance is dynamic. It is influenced by the density, the composition, and the angle of the particles, creating a continuous, shimmering, self-illuminated tapestry that evolves with every orbital turn. Embedded within this icy tapestry are occasional larger bodies, moonlets or clumps that have grown slightly more substantial than the surrounding fragments. These objects act like small anchors, stirring the ring material around them. As they move, they create patterns similar to the wake behind a boat gliding across still water. These disturbances, often propeller-shaped structures, hint at the presence of something more solid hiding among the icy fragments. Though many of these moonlets are too small to be seen clearly, their influence can be traced through the elegant patterns they create. The behavior of the rings is a remarkable study in balance. Gravity from Saturn guides the overall structure. Subtle forces between particles shape local patterns, and constant collisions smooth out any excesses. Light reveals the beautiful details that are usually hidden. Together, these influences keep the rings delicate and dynamic. They are not frozen in time. They shift, shimmer, and slowly evolve. Though the changes are often too gradual to notice across a short span, they are the quiet signature of a system that is continuously alive with motion, a self-organizing beauty that emerges naturally from the fundamental laws of motion. In this mesmerizing, constant dance of a billion pieces of ice, we find quiet assurance. Order does not need to be forced. It can arise gently, almost effortlessly, when balance is allowed to form. The constant soft movement does not lead to chaos. It leads to breathtaking structure, a frozen, enduring piece of cosmic art. Saturn's rings, for all their delicate, glittering appearance, are not left to drift without guidance. Though they may appear to be an effortless arrangement of icy particles, their structure is quietly shaped and maintained by invisible forces that work with exquisite precision. This is the domain of sculpting the silence, where small, unassuming moons and the profound mathematics of orbital rhythm keep order within the grand, icy disk among Saturn's rings. Scattered near, and even within the structure, are several small moons. Some are only a few tens of kilometers across, hardly impressive compared to the giant planet they accompany, yet their influence is profound. These moons are known as shepherd moons because they play a role much like that of a shepherd guiding a flock. Just as a shepherd keeps sheep from wandering too far, these moons help maintain the sharp edges and delicate structures of the rings. Without them, Saturn's rings would look far more diffuse, edges would blur, and the elegant divisions between ring sections would soften over time. To understand how these moons keep order, imagine a pair of tiny moons orbiting very close to a narrow ring. One moon orbits just inside the ring's edge. As it travels, its gravity gently tugs at the particles, pulling them slightly inward. On the other side, the second moon orbits just outside, pulling particles outward. Between these two gravitational influences, the ring material becomes confined, almost as if held gently between two invisible hands. This arrangement helps maintain crisp boundaries, preventing particles from spreading too far. One of the most famous examples of this celestial teamwork involves the F-ring, a narrow, delicate band that often appears braided or knotted. This unusual, complex structure is due in part to the tiny moons Prometheus and Pandora, which orbit on either side of it. As they move, their gravitational pulls gently nudge the ring material, creating waves, knots, and intricate structures. Prometheus, in particular, occasionally grazes slightly into the F-ring, dragging material with it and leaving behind streamers like a hand gently ruffling the surface of water. Pandora follows outside, helping to keep material from drifting. The result is a constant, gentle push and pull that creates a living, shifting piece of cosmic art. These shepherding effects are not limited to narrow rings. They extend across the entire system. But the rings are also shaped by something far more subtle and deeply mathematical: orbital resonances. These occur when ring particles and moons fall into matching gravitational rhythms, like dancers keeping time with the same rhythm. A resonance happens when the orbital period of a moon and the particles in a particular part of the ring fit into a simple numerical ratio. For example, a 2.1 resonance would mean that for every one orbit a moon completes, a particle in that specific location completes exactly 2. With each repeated alignment, the moon's gravity gives the particle a small, predictable nudge, a whisper of force that over time accumulates into powerful results. These repeated gravitational tugs can clear out ring material from certain zones, opening gaps. The Cassini division, the wide, dark space separating the A and B rings, is one of the clearest examples. A moon named Mimas, orbiting farther out, plays a key role here. Particles attempting to orbit in the region of the Cassini division meet Mimas in a 2.1 resonance, receiving regular, timed gravitational nudges that gradually destabilize their orbits and cause them to drift into different regions. As a result, the space in that resonance becomes sparsely populated, forming the wide, dark division we see today. Resonances do not only clear space, they can also create structure within the rings themselves. When the gravitational nudges are not strong enough to open a full gap, they may instead generate beautiful, mesmerizing waves that propagate through the rings. These are called density waves, and they ripple through the ring material much like sound waves travel through air. Rather than hearing them, we see them as patterns, gentle, spiral ripples where the ring material becomes slightly more concentrated in some areas and more spread out in others. There is a poetic quality to these density waves. They resemble musical patterns frozen in ice, each crest and trough marking the quiet influence of a distant moon's gravitational note. Scientists sometimes refer to them as silent music or frozen harmonies because they capture the idea of motion and sound, yet they play out across a canvas of ice and shadow rather than air. Spiral density waves are not static. They move, shift, and slowly unwrap over time, revealing the delicate choreography of ring particles responding to unseen rhythmic commands. All of this, the shepherding of tiny moons, the clearing of gaps. The formation of waves happens without any conscious guidance. There is no central command telling the rings how to behave. Instead, order emerges naturally from motion. It is a remarkable example of how the universe finds patterns in chaos. Ice particles orbit Saturn, moons circle beyond them, and gravity quietly orchestrates their interactions until breathtaking structure appears. The rings are not static decorations but dynamic, ever-adjusting artworks. They teach us that motion and harmony are not opposing ideas. They can coexist. The constant movement of countless particles does not lead to chaos. It leads to breathtaking structure. They shine because sunlight finds a million tiny mirrors, and they appear smooth because gentle collisions soften the rough edges. To watch the rings is to witness the poetry of physics, a quiet symphony played out in ice, dust, and the subtle, persistent pull of gravity. Far from the warmth of the inner solar system, Saturn glides through space surrounded by an invisible companion, a powerful, yet strangely quiet, magnetic field. Although you cannot see it with the eye, this field shapes the space around the planet, guiding charged particles, shaping auroras, and forming a protective bubble against the solar wind. This is the Whispering Shield, a subtle force that gives Saturn a profound connection to the wider cosmos. Saturn's magnetic field is familiar and peculiar. It is familiar because, like Earth, it creates beautiful, shimmering auroras at its poles. But it is peculiar because it appears to be aligned almost perfectly with its axis of rotation. This near-perfect symmetry is so precise that it has puzzled scientists for decades, raising deep questions about how such a configuration can exist and what it reveals about the planet's deep interior. A magnetic field around a planet acts like an invisible shield. It deflects charged particles streaming from the sun, wrapping the planet in a protective cocoon called a magnetosphere. On Earth, this magnetosphere shields the surface from harmful radiation and channels some particles toward the poles, where they produce the well-known auroras. Saturn's magnetic field performs a similar role, though on a far grander scale. Because Saturn is enormous and spins so rapidly, its magnetic field stretches out into space in an immense structure that continually interacts with the solar wind, forming a vast, flowing system. At the heart of Saturn's magnetic field lies the source of this invisible force. As we explored the inner structure deep within the planet, pressures become so extreme that hydrogen turns into the exotic state known as metallic hydrogen. In this form, hydrogen behaves like a metal, conducting electricity. Circulating flows of this metallic hydrogen generate Saturn's magnetic field through a process called the dynamo effect. The concept is similar to how electricity flowing through coils of wire can produce a magnetic field, except that Saturn's wires are vast streams of metallic hydrogen swirling around under crushing, unimaginable pressure. This internal motion creates the powerful magnetic field that extends far into space. For most planets, including Earth, the magnetic field is tilted relative to the axis the planet spins on. On Earth, the magnetic North Pole and the geographic North Pole are not in the same location. This tilt causes the magnetic field to wobble as the planet rotates, allowing scientists to measure this consistent wobble to precisely determine the length of the planet's day. Saturn, however, does not cooperate so easily. Its magnetic field is aligned almost perfectly with its rotation axis. Imagine a spinning top with a faint lamp strapped to it, shining straight upward. If the lamp is aligned perfectly with the top's spin, someone watching would see a constant glow with no wobbles or variations to measure. Saturn behaves in a similar way. Its magnetic field appears so neatly aligned that it produces no obvious magnetic pulse or wobble for scientists to use to time its rotation. This near-perfect alignment is one of Saturn's great mysteries. The laws of physics that explain magnetic fields inside planets suggest that such a precise alignment should not be stable over long periods. Something, it seems, is helping Saturn maintain this elegant configuration, or perhaps masking the true tilt. It is as though Saturn keeps part of its internal rhythm private, allowing only glimpses, but never revealing the full score. Despite the difficulty in measuring Saturn's rotation because of this paradox, the magnetic field itself is anything but weak. It forms an enormous bubble around Saturn known as the magnetosphere. As Saturn orbits the Sun, the shape of this magnetosphere shifts and stretches, influenced by both the solar wind and Saturn's own constant rotation. Within this magnetic bubble, charged particles become trapped and guided along the magnetic field lines, spiraling toward the poles. When these particles reach Saturn's upper atmosphere, they collide with the gases and produce light, the auroras. On Saturn, the auroras glow softly in the ultraviolet and infrared ranges, often invisible to human eyes without special instruments. Yet, if you could see them, they would appear like glowing curtains or rings of light wrapped around Saturn's poles, often forming more structured ovals than Earth's dancing displays. The most fascinating feature of Saturn's auroras is that they are not driven only by the distant Sun. Some are influenced by activity from Saturn's own system. For instance, the Moon Enceladus sends plumes of water vapor and icy particles into space through geysers at its southern pole. These particles become charged and feed directly into Saturn's magnetosphere, adding material that contributes to the auroral activity. It is as though Saturn draws not only from the distant star that illuminates it, but also from the worlds that orbit it, weaving their contributions into the shimmering glow at its poles. It is unusual to think of a magnetic field as something peaceful, but Saturn's is. It works quietly, steadily, almost politely. There are no sudden jolts or violent storms tearing across the atmosphere as a direct result of the magnetic field. Instead, its influence forms an almost meditative cycle, particles drawn in, guided, released as light, then carried away again. The auroras do not roar or crackle. They simply glow like the faint exhale of a sleeping giant. To reflect on Saturn's magnetic field is to appreciate how much of our universe is made of things we cannot see directly. Invisible forces shape worlds, guide particles, and create displays of light so beautiful they rival any sunrise. Saturn reminds us that some of nature's most remarkable structures do not proclaim loudly. They work quietly, steadily, and with grace. The magnetic field, rather than roaring with energy, hums like a soft background note in a musical piece. It is the core of Saturn's quiet authority. Among Saturn's many moons, one stands out as a world with a personality entirely its own. We turn our attention now to Titan, Saturn's largest satellite, a place where the familiar structure of Earth has been transformed by alien chemistry and intense cold. It is a place with weather, landscapes, rivers, and seas, a world we can call the methane mirror. Titan is wrapped in a dense, permanent atmosphere. So dense, in fact, that it is thicker than Earth's. Standing on Titan's surface would feel more like being inside a deep, cushioned fog than the airy space we know. The pressure at the surface is about 1.5 times that of Earth's sea level, creating a surprisingly comfortable atmospheric pressure for a human body. If one could somehow ignore the freezing temperature and the lack of oxygen, the atmosphere would feel familiar, as it is composed mostly of nitrogen, just like Earth's. This is a rare, Earth-like whisper among the many worlds of the outer solar system. But the temperature quickly reminds us how alien this place is. Far from the distant sun, Titan is intensely, profoundly cold, with surface temperatures hovering around 179 degrees Celsius. At such cryogenic temperatures, water is as solid as rock. So solid, in fact, that ice forms Titan's mountains, its bedrock, and its entire crust. To Titan, water is what granite is to Earth. In this frigid environment, another liquid takes center stage: methane. On Earth, methane is a gas that escapes into the sky with ease. But on Titan, methane is cool enough to behave exactly like water. It condenses into clouds, gathers into droplets, and falls as rain. Titan has a complete methane cycle that perfectly mirrors Earth's water cycle. Methane evaporates from lakes, forms clouds, drifts across the sky, and returns to the surface as rain. The idea of methane raindrops falling onto icy ground may sound unsettling, yet it tells us that Titan possesses something incredibly rare among moons: active weather. A stroll across Titan, if such a stroll were possible, would reveal landscapes shaped by this methane weather. Methane rain carves valleys, forms river channels, and collects in vast, dark lakes and seas. These are not poetic metaphors, but real bodies of liquid pulled onto Titan's surface, some hundreds of kilometers across. They rest near the moon's poles, where the climate is slightly cooler, and the methane and its cousin, ethane, stay liquid for long periods. The largest of these seas, such as Kraken Mare, are vast enough to imagine sailing across, though the vessel would need to withstand the intense cold and sail through liquid hydrocarbons rather than water. In Titan's equatorial regions, where rainfall is less common, dunes stretch across the landscape in long, sweeping lines. These features resemble those seen in Earth's deserts, yet the grains making them are not sand as we know it. Instead, they're composed of tiny bits of organic material that have fallen like slow chemical snow from the upper atmosphere. The wind pushes these grains into dunes that can grow hundreds of meters tall and stretch for kilometers, quietly sculpted by Titan's gentle breezes. Titan's skies are never perfectly clear. The moon is constantly bathed in a soft golden haze that filters sunlight into a dim, constant amber glow. This haze gives Titan a dreamlike quality. Even during the day, standing on Titan would feel like being out during twilight on Earth. The distant sun would appear only as a bright, far-off dot, more like a lamp than a blinding disk. Light would be scattered through the dense atmosphere, making shadows softer and colors muted. Time would feel slower, the light subdued, as if the world itself were wrapped in a gentle blanket of calm. The scale of Titan's features invites comparison to Earth's natural wonders, yet these emerge through a completely different chemistry. The crust beneath the surface is made of water ice, as solid as rock. Beneath that icy crust, there may even be a hidden layer of liquid water warmed by internal heat. But at the surface, the roles have been reversed. Water becomes stone and methane becomes the life-shaping liquid. Titan is an echo of Earth, heard through a thick, frozen filter. It is a world that breathes through cycles so slow and cold that patience is needed to appreciate their beauty, yet cycles that resonate with those familiar to us. Skies, clouds, seasons, rainfall, rivers, dunes, and seas, all made of substances that would astonish any earthbound observer. Titan stands as a place where the familiar structure of a planet is manifested through the most alien materials, demonstrating that nature can craft familiar patterns from the most unfamiliar tools. It is both comforting and strange, both recognizable and otherworldly, a silent, serene realm of flowing methane and eternal ice. Far from the warmth of the sun, orbiting in the frozen suburbs of the solar system, lies a moon that seems far too small and too cold to be of great importance. Yet, Enceladus, a gleaming pearl only a few hundred kilometers across, has become one of the most exciting places in the search for life beyond Earth. Beneath its bright, icy exterior lies a profound secret, a global ocean of liquid water hidden under a shell of ice. And unlike many quiet ocean worlds, Enceladus is not shy about revealing what lies within. It sends its ocean into space in great, shimmering plumes, as if proudly announcing, "There is something remarkable here." If you were drifting near Enceladus, your first impression might be of a world carved from pure, brilliant ice. Its surface is dazzling white, the brightest in the solar system, reflecting sunlight as if coated in fresh, untouched snow. Cracks, ridges, and smooth plains of ice cover the surface, giving the moon a sculpted, frozen appearance. But toward the South Pole, the ice tells a different story. There, long, dark stripes stretch across the surface like tiger stripes, fractures in the ice where something warm and active breaks through. These fractures are the source of the Enceladus plumes, jets of water vapor, icy grains and organic molecules shooting into space from beneath the surface. They vary in strength, sometimes billowing like vast geysers, sometimes quieter, but they are persistent, a steady exhalation into space. The idea of water erupting from a frozen moon in the cold outer solar system seems almost contradictory. Yet Enceladus has made it real. Spacecraft, most notably Cassini, have flown directly through these plumes and gently tasted their contents, gathering direct evidence from the particles and vapor that escape from the hidden ocean below. The existence of these plumes is extraordinary for several reasons. First, they provide direct access to material from the ocean without the need to drill through kilometers of ice. Most ocean worlds keep their water guarded by miles of frozen crust. Enceladus, however, delivers samples freely into space. Second, the plumes reveal what the ocean contains. By analyzing the particles, scientists have found water, salts, organic compounds, and even microscopic grains of silica, tiny clues that hint at what is happening deep within. Multiple lines of evidence now point towards something far greater than just small pools of water. They point toward a global ocean encircling the entire moon beneath the ice. Gravity measurements taken during spacecraft flybys have shown that the moon wobbles slightly as it orbits Saturn. This wobble would not occur if the interior was solid. Instead, it behaves like a ball containing liquid beneath its crust. A global ocean alone would be enough to make Enceladus fascinating, but what truly elevates it is the likelihood of hydrothermal activity. Deep on the ocean floor, where the water meets the rocky core, there may be hydrothermal vents, places where seawater interacts with hot rock, becomes enriched with minerals, and rises back into the ocean. On Earth, such vents form oases of life, supporting entire ecosystems independent of sunlight through chemical energy alone. If similar vents exist on Enceladus, they could create habitable environments powered by chemistry in the eternal dark. The strongest hint of hydrothermal activity comes from silica particles in the plumes. Their composition suggests they formed in contact with hot, mineral-rich water at temperatures of at least 90 degrees Celsius. For such conditions to exist on Enceladus, there must be heat flowing through its rocky core, warming the ocean where it touches the rock. This heat likely comes from tidal forces. Enceladus orbits Saturn in a rhythm, a relationship known as an orbital resonance with another moon. This gravitational interaction stretches and squeezes Enceladus slightly as it moves, creating internal friction that produces heat. It is a gentle but persistent kneading of the moon's interior. Over time, this tidal heating prevents the ocean from freezing solid, and may even drive the hydrothermal processes that support complex chemistry at the ocean floor. The presence of organic molecules in the plumes, including complex carbon-based compounds, further heightens intrigue. While the presence of organic chemistry does not prove life, it shows that Enceladus has many of the ingredients associated with habitability. Water, energy sources, minerals, and organics are all present. There is a serene beauty in the thought that beneath a sheet of ice, in a moon smaller than the width of France, a warm ocean might cradle the ingredients of life. Enceladus is not loud or imposing. It does not have towering storms to announce its potential. Instead, it whispers. Its plumes rise delicately into space, shimmering with hints of what lies below. They curl outward, fall as snow back to the surface, and leave fine frost on the terrain. It is a quiet revelation world. Enceladus challenges the idea that habitability requires warmth from a star. Instead, it shows that internal heat and water can create pockets of potential life deep underground. It asks us to consider that the first footsteps toward life somewhere else in the universe may not resemble Earth's beginning at all, but might start in the dark, in warmth born of gravity's steady tug. It stands as a testament to the universe's creativity, a quiet masterpiece of possibility beneath the ice. Among Saturn's many satellites, some are serene, some are profound, and some are just delightfully, wonderfully odd. Beyond the vast, life-bearing potential of Titan and Enceladus, Saturn's system is filled with smaller, more eccentric companions, each carrying a distinct personality shaped by ice, rock, and the strange gravitational conditions of life in Saturn's neighborhood. We now drift into the company of these eccentric companions, the quirky oddballs of the outer solar system. One of the most striking of these worlds is Iapetus. At first glance, Iapetus looks as if someone dipped half of the moon in dark, light-absorbing soot and left the other half bright and icy white. One hemisphere is jet black, absorbing almost all the sunlight that touches it, while the other gleams a brilliant white. The contrast is so dramatic that Iapetus resembles a cosmic yin and yang, a world divided into light and darkness in both color and character. This extreme dual coloring is believed to be caused by a combination of materials swept up from space and a self-heating process that causes water ice to sublime and redeposit, as if that visual puzzle were not curious enough. Iapetus also sports a colossal, unexplained ridge running almost perfectly along its equator. This feature can rise more than 10 kilometers high, taller than Mount Everest, and stretches for hundreds of kilometers, making the moon look like a walnut or perhaps a celestial football with a seam. The origin of this enormous equatorial ridge remains one of the solar system's charming unsolved puzzles, possibly the remains of a once fast-spinning moon that slowed down, leaving its equator frozen in an immense, permanent bulge. If Iapetus looks sculpted and deliberate, Hyperion seems like an art experiment left unsupervised. This moon resembles a giant porous sponge or a piece of fossilized coral pocked with deep, sharp-edged craters that give it a texture unlike any other moon in the solar system. Its low density suggests that it is not solid through and through, but rather a loosely packed, icy body full of voids. Hypothetically, landing on Hyperion would feel like walking across frozen, airy foam. Hyperion's behavior is as unusual as its appearance. Rather than rotating smoothly like a spinning top, Hyperion tumbles chaotically through space. It does not have a consistent day or a fixed orientation. Instead, it wobbles unpredictably, its rotation influenced by nearby moons and Saturn's gravitational pull. Watching Hyperion's spin is like watching a tossed pebble tumble through the air, except the pebble is hundreds of kilometers across and has been tumbling in its chaotic dance for millions of years. A delightful curiosity that refuses to settle into a neat, predictable rhythm. Then there is Mimas, a moon that bears a gigantic impact crater named Herschel, which dominates one side of its surface. The crater is so large relative to the size of the moon that it gives Mimas the unforgettable appearance of a certain armored space station from classic science fiction films. The crater is a dramatic reminder of how powerful ancient impacts can be. Had the strike that created Herschel been much stronger, it might have shattered Mimas entirely. Despite its modest size and quiet appearance, Mimas plays a crucial, subtle role in orchestrating the dynamics of Saturn's rings, as its gravitational tug is the primary sculptor responsible for maintaining the wide, dark Cassini division. Beyond these headline-grabbing oddities, Saturn's system is filled with smaller companions that contribute their own quirky charm. Take the moons Janus and Epimetheus, which perform a celestial dance unlike anything else in the solar system. These two moons share nearly the exact same orbit, and rather than crashing into each other, they gracefully swap positions every few years. When the inner moon catches up to the outer one, their gravitational interaction causes them to exchange orbits, with one drifting outward and the other drifting inward. It is a stable pattern of cosmic cooperation, a gentle pirouette on the grand stage of space. Other tiny shepherds, like Pan and Atlas, orbit within the rings, clearing paths and gathering ring material around their equators, which gives them a distinctive dumpling or ravioli shape. They seem to wear little icy skirts grown from the material they gently sweep up over time. Their unusual shapes are a lovely, light-hearted example of how gravity and motion mold small bodies in unexpected ways. Saturn's moon family is not just a collection of spheres orbiting a planet. It is a collection of stories written in ice, craters, and curious shapes. What makes these moons so charming is their profound individuality. Each one, from the sponge-like Hyperion to the walnut-shaped Iapetus, seems to have developed a personality shaped by physics, ice, and time. They remind us that even in the colder, quieter corners of the solar system, nature delights in variety. Wandering among these moons would feel like moving through a gallery of sculptures, each piece carved by gravity and cosmic history. They show that the universe has a sense of creativity, turning the seemingly impossible into the wonderfully real, ensuring that the rings are not just static decorations but part of an immense, lively neighborhood of eccentric companions maintaining the graceful equilibrium of the Saturn system. We now arrive at the conclusion of this quiet journey, allowing the vast, intricate picture of Saturn to settle softly in our minds. As we reflect on all that we have drifted through, the rings, the atmosphere, the moons, we realize that Saturn is not simply a planet of beauty, but a planet of profound, enduring contradictions. It is a world that seems, at first glance, as though it should not exist, yet it persists with an effortless grace, holding all its impossibilities in perfect harmony, the final equilibrium. For many, the central contradiction begins with Saturn's physical nature. How can a planet so colossal, so massive in scale, be made of the universe's simplest, lightest ingredients? Saturn is enormous yet buoyant, capable of theoretically floating on water. It is a giant made of the most delicate elements, yet its gravity is mighty enough to command dozens of moons and sculpt an entire, intricate system of rings. Saturn teaches a soft yet powerful lesson. Size and weight are not equal. It is possible to be immense and yet light, powerful and yet gentle. Then there are the rings, perhaps the most iconic paradox of all. They appear eternal and solid from afar, like a celestial emblem, yet up close they are revealed to be impossibly thin and fragile, a collection of countless icy fragments constantly shifting. They should, by all logical expectations, scatter, fall apart, or disappear quickly. And yet they endure, surviving through cosmic seasons by finding a delicate balance between motion and gravity. Their beauty lies not in permanence but in equilibrium. They are a continuous, fleeting masterpiece, reminding us that fragility does not prevent endurance. Saturn's atmosphere carries this same quiet contrast. Its soft pastel stripes give the impression of stillness, yet beneath that serene appearance swirl winds that race faster than almost any found on Earth, generating storms the size of continents. The famous hexagon at the pole is a pattern shaped not by rigid design, but by the relentless, organized flow of turbulence. What we might first label as chaos transforms through the laws of physics into lasting, harmonious order. Here, Saturn demonstrates that order can emerge from turbulence, and that harmony can rise from the most extreme conditions. Even Saturn's moons contribute to this theme of contradiction. Titan offers lakes, rivers, and rain, but of methane, creating familiar landscapes from an alien chemistry. Enceladus, small and icy, should be frozen solid, yet it harbors a global ocean of liquid water, kept warm by the subtle, gentle gravitational flexing of its tides. These worlds are successful precisely because they found unconventional solutions to the harsh conditions of the outer solar system. Saturn does not exist in defiance of the rules of reality, but rather by expressing those rules in their most complex and graceful form. Every unlikely feature of Saturn becomes natural once the full story of its formation, behavior, and evolution unfolds. This planet embodies the comforting truth that what seems impossible is simply not yet understood. It takes contradictory qualities, lightness and strength, fragility and persistence, chaos and order, and shows that these can coexist without cancelling each other out. In Saturn, they are not opposing forces. They are complementary ones. This planet invites a gentle, final reflection on our own expectations. How often do we assume that strength must look a certain way, or that things meant to last must be rigid and heavy? Saturn shows another path. Strength can be quiet, and longevity can arise from balance rather than force. The rings, delicate as frost, have lasted through immense spans of time by flowing with the laws of motion rather than rigidly resisting them. The entire system is a continuous lesson in equilibrium. Saturn reassures us that the universe can be both logical and beautiful, not one or the other. It is proof that the cosmos is not just a place of cold equations, but of artistry shaped by physics. As this journey settles in your thoughts, allow a quiet appreciation for the planet's profound contradictions. They are not flaws or puzzles, but part of what makes this world so captivating. Saturn is a reminder that wonder often lives just beyond the boundary of what we think we understand. And now, as we come to the very end of this gentle journey, allow the complete image of Saturn, the immense, light sphere wrapped in its whispering rings, surrounded by its strange, warm moons, to linger softly in your mind. A world where contradictions match effortless grace. A peaceful reminder that even in the vastness of space, harmony can emerge from complexity, and beauty can arise in the unlikeliest of places. Thank you for drifting through this cosmic story, for letting your imagination wander across icy rings and moonlit skies, and for spending this quiet time exploring one of the universe's most poetic worlds. If your eyes are growing heavy, feel free to let the thought of Saturn accompany you into sleep, a quiet image of balance, patience, and serenity. For now, rest well and let the universe hold its quiet watch over you. Good night.